Morning, gentlemen, welcome back. Today we're looking at a very important subtopic on the matrices, and that is multiplying a matrix by another matrix. An extremely important topic, and if you don't get this topic going forward in matrices, it's going to be a little bit tricky. So it's very important that you pay attention to how a matrix is multiplied by another matrix. But before we even proceed, there's something extremely important. Now, straight away, I'm letting you guys know that you cannot take up any two matrices and multiply them together. You cannot just randomly take up any two matrices and try to multiply them together, because there has to be a condition that exists in order for you to be able to multiply two matrices. So any two matrices don't necessarily can be able to be multiplied, because there exists a special condition under which two matrices can be multiplied. So let's look at that condition. Now, here's the condition in question. So it says here, two matrices can be multiplied to each other if, and only if, the number of columns, notice it says columns here, the number of columns of the first matrix equals the number of rows of the second matrix. Now, that's a condition that has to exist in order for two matrices to be able to multiply to each other. So again, two matrices can be multiplied to each other if the number of columns of the first matrix equals the number of rows of the second matrix. All right, so let's look at what that is saying. And sometimes by the end of this video, you won't have to try to remember this. There's just a little trick that we can do looking at two matrices to determine whether we can multiply them or not. All right, so that's what we're going to look at. So you don't have to remember word for word the condition. After you've looked at the video, then you'll be able to quickly determine whether two matrices can be multiplied or not. All right, so let's start the ball rolling. So here's a scenario. Now, based on the condition discussed, this condition that we just looked at, based on that condition, two matrices cannot be multiplied to each other if the number of columns of the first matrix equals the number of rows of the second matrix. That's the condition that they're talking about. So based on the condition, and we're given two matrices here, which do you think is possible? Now, the first thing I want to do is to look at matrix A. The order of matrix A is 2 by 2. I think we mastered the order of a matrix by now. And the order of matrix B is obviously 2 by 1. Now, it is very important to state the orders of the matrices before we proceed. So it says, which do you think is possible? B times A or A times B? So obviously in the first one, B would be the first matrix and A would be the second matrix. In part 2, A would be the first matrix and B would be the second matrix. So let's look at the first part. Now, just going to put that there. And we're just going to look at it as is. So for part 1, they're asking us to determine B times A. Now, the order of matrix B is 2 by 1, and the order of matrix A is 2 by 2. Now, we know that the first number, when we're talking about the order of the matrix, the first number is dealing with row and the second is dealing with column. Same thing here, row and column. Now the condition says that in order for two matrices to be able to be multiplied to each other, the number of columns of the first matrix, so in this particular case B is the first matrix, and the number of columns of the first matrix B is 1. So it says two matrices can only be multiplied to each other if the number of columns of the first matrix is B, and the number of columns is 1. And it says must be equal to the number of rows of the second matrix. Now the number of rows of the second matrix is A, and the number of rows is 2. So in other words, these two numbers in order for you to be able to multiply two matrices, those two numbers must be equal. The number of columns of the first matrix must equal the number of rows of the second matrix. So my question is, do those two numbers equal each other? And the answer to that is no, which means that cannot happen. So we cannot multiply B times A, right? So in this particular case, B is the first matrix and A is the second matrix. Multiplication cannot occur simply because the number of columns of the first matrix B does not equal the number of rows of the second matrix A. Multiplication cannot occur. So that means that this cannot happen. That can't work. All right? Now, let's look at part 2 now. Let's look at part 2. Now, part 2 says A times B. Now, the order of matrix A is 2 by 2, and the order of matrix B is 2 by 1. Now, let's take a look at that. Remember again the condition. The condition says two matrices can only be multiplied to each other if the number of columns of the first matrix, now remember the first matrix here is A, so let me just denote again. This is row, column. Row always comes first and then column. All right, so row, column. So it says two matrices can only be multiplied to each other if the number of columns of the first matrix equals the number of rows of the second matrix. So you can clearly say that A is the first matrix and the number of columns is 2. B is the second matrix and the number of rows is 2. So the thing is, those two numbers are exactly the same. So it means that multiplication can occur. So A times B can happen. Now there's something else that is very important and will help you when you're multiplying matrices. Now that I know that, based on the fact that the number of columns of matrix A, the first matrix, is equal to the number of rows of matrix B, which is the second matrix, that both of the numbers are equal, and I know that they can be multiplied, there is also something else that is extremely important. So the long and short of it is that the inner numbers, once the inner numbers are the same, that you can multiply. Once the inner numbers are the same, I call these outer numbers inner numbers. So once the inner numbers are the same, you can multiply. And the outer numbers, very important, the outer numbers here will tell you what kind of matrix you should end up with when you multiply A times B. And that's the magic of doing it this way. So I know that I can multiply A times B because the inner numbers are the same, and the outer numbers, this 2 here and this 1 here, will tell me that when I multiply A times B, I should end up with a 2 by 1 matrix, which means I should end up with a matrix that looks something like this. That's a 2 by 1. So when I multiply A times B, my answer should look like that. And that's what the outer numbers tell you. But you can only look at the outer numbers if the inner numbers are the same, and it means that you're good to go with multiplication. All right? So that is with regards to the condition under which you can multiply two matrices. So let me demonstrate, how you multiply A times B. So let's get the ball rolling here. So remember, this is matrix A and this is matrix B, and remember that based on what we discussed, that this here can in fact happen. All right, so I'm going to show you now how to multiply A times B. So let's get the ball rolling with that. So A times B, and remember, based on this discussion, the inner numbers are the same. That means we're good to go with multiplication, and we should end up with a 2 by 1 matrix, which looks like this. So our answer should look like that. So let's proceed. So the first matrix is A, and that is that matrix over there. So we're going to write 1, 3, 4, and 6. And matrix B is the second matrix, and that is over there, which is 5 and 2. Now, let me show you how we multiply matrices now. So here's what we're going to do. Now, when you're multiplying matrices now, notice now in the first column you have 2 rows. So I'm going to deal with the first row here that has elements 1 and 3. And the first column. Well, in the second matrix there is only 1 column. So it makes this multiplication very, very easy. But essentially, starting with first row, first column. So first row of the first matrix, first column of the second matrix. So when I multiply these two, I'm going to really end up with x. So I'm going to show you how to do this now. Very straightforward. Remember, the answer should look like this. So this times this is going to give me that element right there. All right, and that is why it is important to make a note of what your answer should look like. And that's a good thing about it. So let's proceed with this. So we're going to have 1 times 5. So 1 times 5 plus, very important, a lot of students leave out this. Very important because you're going to end up with this. A lot of students make the mistake and do 1 times 5 here and then go over here and do 3 times 2 and end up with a 2 by 2 matrix. But you already know, based on the outer numbers, what kind of matrix you should end up with. That is very important. So it is 1 times 5 plus 3 times 2, and that is going to give me element x. Now listen very carefully. Now that I've used the first row and multiplied by the first column, you see, if this matrix B here had more columns going across, I would stick with the first column and just keep going with those. Sorry, stick with the first row and keep going with with the amount of columns until I finish. Now, there are no more columns in the second matrix because matrix B only has 1 column. So I can't do anything more with this because I run out of columns now. So what I have to do now to get this element is to move down to the second row and multiply the second row by that column. And that's how you do it. So I only move down to the next row when I've diminished the amount of columns to work with. I've seen that there's just one column in the second matrix. Then I can't use this anymore. So I just move down to the second row and start the process all over again. So for this one, what would it be? 4 times 5 plus 6 times 2, and that would give me element y. All I have to do from here is tidy up. So it would be 5 plus 6, 20 plus 12, and the final answer would be 5 plus 6 is 11, and 20 plus 12 is 32. And obviously this is a 2 by 1 matrix, which looks like this here. So knowing what your answer should look like is a big help so you don't make any mistakes when you're doing these things here. So this is what we should end up with. And that is what we did, end up with a 2 by 1 matrix. And that is how you multiply matrices together. All right, I'm just going to do one more and then break this video because we're already 13 minutes into the video. So let's take a look at this. Let's take a look at this question here. So given matrix G and matrix H, determine G times H. So let's put this over here. First of all, it is always a good idea to write the order quickly. So what's the order of this matrix? The order of this matrix, we have 3 rows and 2 columns. So the order of matrix G is 3 by 2, and the order of matrix H is 2 by 1. So we know the order, which is going to be very important before we attempt to multiply. So let's get into the business of multiplying. All right. So we're trying to multiply G by H. And again, the order of matrix G is 3 by 2. The order of matrix H is 2 by 1. What do the inner numbers tell you again? The inner numbers tell you that if they're the same, multiplication is good to happen. And the outer numbers, importantly, what do the outer numbers tell you? What your answer should look like, meaning your answer should be of the order 3 by 1. And a 3 by 1 matrix looks like this. You should be able to agree with me. This is a 3 by 1 matrix. So the answer should look like that. So let's proceed. The matrix that comes first is G, and that matrix is 5, -3, 1, 4, 0, 6. And second matrix is H, which is 8 and 2. And we know that our answer should look like that. So let's proceed with multiplying these two matrices. Again, first row, first column. Well, matrix H only has one column, so that's the only column we're going to work with. It means that we're going to use the rows one time. So this times that is going to give me this. So let's proceed now with the multiplication. So this is going to be 5 times 8, so 5 times 8 plus -3 times 2. If you want to put the first 2 in bracket and the second 2 in bracket, no problem. Now, because we don't have any more columns, we're not using this anymore. So that means we move down to the second row and then multiply by the column to get this element. Again, please to do this so you know what your answer should look like. So this will be 1 times 8 plus 4 times 2. 1 times 8 plus 4 times 2 to give us element B. Again, there are no more columns, so we can use this row again. So we go here and start the process all over again to give us element C. So this would be 0 times 8 plus 6 times 2. So what we'll have is 40 plus -6, 8 plus 8, 0 plus 12. For your final answer of 40 minus 6 is 34, 8 plus 8 is 16, and 0 plus 12 is 12, which is obviously a 3 by 1 matrix, which looks like that one up there. So it can clearly determine easily if two matrices can be multiplied to each other, and it can clearly determine what your answer should look like, which means what is the order of the matrix that you should end up with. All right, so I'm going to end the video here. In the next video, we're going to look at other examples that is going to expand the dynamics in multiplying matrices. All right, so I hope you guys found this video insightful, and I'll see you guys on the next video.